Hey everyone, it's Skylar here, and today I've got a random piece of coax and I want to figure out the length, and I've got nothing but a multimeter. Well, and I happen to be near an outlet, an AC power outlet, so can I figure out the length of this coax with just a multimeter and an AC power outlet? Okay, well, here's my coax. It's some length. I have no idea where it came from or what it is, and I don't want to open it up because unless I know what length it is. I do know what type of coax it is, so I can get the specs on that. I've got a multimeter, and then I've got a power source right here. 120 volts AC at 60 hertz. So, one other thing. I was going to just alligator clip up directly to it, but, you know, maybe it's a little safer to use something. So I just have a little end flange connector, goes to bare wire, or in my case, some terminal lugs on the other end. Good enough. So let's connect this coax up. And then I'm going to hook one end into this outlet, other end into the multimeter. And to test this outlet real quick, make sure we're not on current mode. I'm just gonna go to AC mode, volts AC, plug it in, and this is the stupid type of outlet where it has those little shingle shades, whatever you want to call it. So I gotta plug in both at the same time, and that's the key that lets me in. No voltage on it. Well, that's because the GFI is tripped, and that makes it a nice switch. So let's just turn it on real quick. Oh, still no voltage. Oh, there we go. Wasn't making contact. So depending on how good my contact is, we got a nice small 120 volts. Nothing to worry about. Just a little over 100 volts. Not dangerous. Okay, so let me turn it back off. I could leave it on. Might as well leave it off while I'm playing with it until I turn it on. And now I'm going to plug in. I'm going to plug in the coax into the outlet. I'm leaving the other end open circuit. Definitely don't want to load on this end. But I'm going to plug this end in. But I want to have some series metering. So let's put this multimeter on microamp mode. Go to the microamp scale. And then let's plug one lead into the outlet and the multimeter into the other lead. Okay, again with these stupid safety features on the outlets, gotta kind of wiggle at them, and then I gotta make sure I'm making good contact. And this wire doesn't like to stick in, so I'm gonna kind of wrap it around, and then that should be good there. But before I go to current mode, yeah, let's just put it in voltage mode, making sure we still measure stuff. AC voltage. And then let me turn the outlet back on. And let's hook ground up to here. We got plus in there. 120 volts, okay. We're making good contact in this outlet. Okay, before I shock myself, let's turn it back off. And let's go back to the microamp range. And I want to go to AC microamps. Then we are going to want to turn our outlet back on. And then I'm just going to probe right here. Not getting anything because I'm still in voltage mode. No. Okay. Now let's just probe like this. Okay, we've got 115 microamps. 116 microamps that this coax is drawing. What? A coax can draw power with an open circuit? There's nothing on the end? Why, yes, it's got plenty of line to give you some series capacitance. So with this figure, we know it's 116 microamps at 120 volts AC. Let's do a little bit of math. I know it's not fun to do math, but let's do a little bit and just see what we get on our impedance based on our reactance of our AC capacitor at 120 volts. And then what we can do from there is back out our coax length based on the specs from this, assuming it's LMR. I think it's some LMR 400 knockoff, so let's assume the specs are similar and try to figure out what length our coax is. Okay, time for the dreaded math. So our voltage was 120 volts. Stupid Sharpie. Let's go with colored pencil. Frequency of 60 hertz. And we got a current of 116 microamps. So now we just need to, what is the capacitor's impedance? So XC, that's just like our voltage over current, so that's V over I equals 120 over 116 times 10 to the minus 6th, which is equal to 103 mega ohms. So that's our impedance, our effective impedance of the capacitor. But we want to actually figure out the capacitance. So we can do that by doing 1 over 2 pi times frequency times the impedance of our capacitor, which equals 1 over 2 pi times 60 times 103 mega ohms, or 103 times 10 to the third, which is equal to 2.57 nanofarads. And I did look up the specs on LMR 400. On this coax, it has a capacitance of 24 picofarads per foot. So if we do 2.57 nanofarads divided by 24 picofarads, we get 107.08 feet, which is pretty close. I think it was probably close to a 100-foot reel, maybe a little more, but anyway, I'm going to call that a win. Now I know I'm around 100 feet where I needed to be. Didn't have to open up that roll of coax, and now I know we don't have like a 50-foot roll or anything, so got us close enough, and all I needed was a multimeter and a 120-volt AC outlet, and we got our coax length. Anyway, hope you enjoyed and learned something new, maybe. I mean, basic capacitance and coax, but hey, I thought it'd be fun to plug in a coax to the 120-volt outlet. So I guess it probably makes a pretty good extension cord. Just use coax next time you need an extension cord. Just make some outlet to coax converters, and you'll be good to go. So anyway, and yeah, it's just 120 volts, so no safety problem there, no safety concerns. So anyway, that's it, and thanks for watching.